Hey guys, in today's video, we're going to be solving the problem delete node in a doubly linked list. So the question says, given a doubly linked list and a position, the task is to delete a node from the given position in a doubly linked list. Okay, so the question says is that let's assume you're given a linked list, doubly linked list, something like this. Okay, and you're given a value x, right? Let's say x is equal to 1, right? And it's a one based indexing. So what the question says is that you need to delete the node at this given position and return the doubly linked list after deleting that node. So if you delete the node at this position, which is 1, and since it's a one based indexing, which means that you need to delete the node 1 from it. If you delete the node 1, you need the returned output doubly linked list would be something like this: 2 3, where the prev of 2 is null, the next of 2 points to 3, the prev of 3 points to 2, and the next of 3 is null. Right, so this will be the returned linked list. Cool. Now, let's assume that the link x is equal to 2. If x is equal to 2, then the returned linked list would be something like this: 1, null, 3, this is null again. These two are pointing to like this, something like this, right? So this is the return doubly linked list when x is equal to 2, and when x is equal to 3, you can guess that it'll be just 1 and 2, right? It'll be something like this: 1, 2, this is null, this is pointing to 1, this is pointing to 2, this is 1, and this is null. So this will be when x is equal to 3. So this is what the question is, guys. Now how are we going to solve this problem? Okay, it's not a very hard problem to solve, so let me just rub all of this once. Okay, yeah, okay. Now, how are we going to solve this problem? Now, to solve this problem, there are three cases we need to keep care of. You know, the first case is when x is the very last node. X is the last node, which is basically over here, which is 3. Second case is when x lies in the middle. And the third case is when x is at the very first node. Okay? X is the very first node. So these are the three cases you need to keep care of. Okay? Now, how are we going to solve the problem? Firstly, let me create a new page and let me create the linked list again. This is 1, this is 2, this is 3. Right, this is null, this is null, this is 1 pointing to 2, 2 pointing to 1, this is 3, this is 1, 2. Right, so when x is, let's solve for the very first case, which is going to be x is equal to 3. Right, the very last node. Right, now since x is 3, the very first step, what we need to do is we need to reach to the node which we need to delete. Right. Firstly, we reach the node which we want to delete. So we need to, if we want to delete the third node, we need to reach the third node. So how are we going to do that? We iterate through the doubly linked list and we reach the last node. So what we'll do is while x is not equal to 1, because this is a one based indexing, not a zero based indexing, we'll do head is equal to head dot next and x minus equal to 1. Right. Now over here, firstly, our head will be this, right? And our x is equal to 3. Now, while x is not equal to 1, we'll do head is equal to head dot next. So this will become head, and our x will be equal to 2 in this case because we'll do minus equal to 1. And since again it's not equal to 1, we'll make head over here, and x is equal to 1 in this case. And since x is equal to 1 now, it will not the loop will stop, right? And we're at this last node at this point over here, right? Now, once we are at the last node, what we're going to do is we'll take head dot prev, which is basically this node over here, and we'll make its next node, which is head dot prev dot next, point to none. That's it. This is all what we're going to do. Now, when we make this point to none, what will happen is we'll get a doubly linked list: 1, 2, like this. This will point to none. Head. This is the head dot prev, which is pointing to 2, and we'll make head.prevs next, which is 2 is next over here, point to none. And when it is pointing to none, this will be like this, and this will point to 2. It's 2 is prev will point to 1, and this will be null. And so this is what this will what we'll get in third case over here when x is equal to 3. So this is for case 1, right? You write this, and in very last you can just write head. And last case you just need to write if. Let me just write it in the next page. While x is not equal to 1, head is equal to head dot next, and x minus equal to 1. Okay. And lastly, what you can just check, if uh, head dot next is equal to none. If it is equal to none, what you can do is you can just make head dot prev dot next equal to none. Okay, this is all what you need to do. Now let's jump. Let's see the three cases again. We've done the first test case. When we've done for the first case over here. Now let's do it for the third case, and then we'll go to the second case because the first and third case are the small ones. Now for the third case, right? Let me do it in a new page. So again, one, two, three. Okay, this is null. This is pointing to two. This is pointing to one. This is pointing to three. This is pointing to two. This is null. Right now, when our x is equal to one, right, the very first step is going to be the same. We need to reach the node which we want to, for which we want to get deleted. We'll do while x is not equal to one, head is equal to head dot next, and x is equal to minus equal to one. Right. When we do this, we're going to be at the very first position itself because head is over here and x is also equal to 1. So we won't actually go inside this loop ever. Right. Because we just check this and it's already x is equal to 1. So we won't go forward. Now, when we want to delete this node, what we'll do is, again, it's the very same thing. We'll do is head dot next. Previously, what we did was head dot prev dot next. And here, what we'll do is we'll do head dot next, which is pointing to 2, and its prev, which is pointing to 1, we'll make it equal to none. Right. We'll make head dot next dot prev equal to none. That's it. This is all what we're going to do. And when we do this, what we'll get is something like this. We'll get 2, 3, right? This is heads next, which is pointing to 2, and it's prev, which is pointing to 1. We'll make it null. So we're making this null, and we're making this point to 3. This is pointing to 2 itself, and this is going to be null. That's it. So you get a linked list like this. Right. So now these are for the two cases which we had. So this is going to be the complete code for it. Let me write it over here itself. If head dot next is equal to none, we can write this. Else if elif head dot prev is equal to none, what we can do is we can just write head dot next dot prev equal to none. Okay. Now for the very last case, when x is this in the middle. Now, when x is in the middle, so let me just go to a new page. Let me just jump to a new page over here, right? Let's see. If 1, 2, 3, right? This is null. This is null. This is 1 pointing to 2, 2 pointing to 1, 2 pointing to 3, and 3 pointing to 2, right? And x is equal to 2. Again, the very first step is going to be the same in all of them. We need to reach the node which we want to delete. So we need to reach node 2, and you already know how we're going to reach the node. Let's just jump to the main part. Now, what we're going to do is, if we want to delete this node, right? Now, how are we going to delete this node? We need to make the pointer of this node, the previous node of 2, which is going to be this node. We need to point its next node to the next node of 2, which is 3, right? So let's just do that first. Now, how are we going to do this? Okay, we can just write head dot prev. So we're going to be, our head is going to be over here. So we're going to do head dot prev dot next is equal to head dot next. Okay. So this is what we're going to do. So we're going to make the pointer of 2's previous node, which is 1. So we can go, we can, access that by making head dot next dot head dot prev dot next. This is head dot prev, which is pointing to 1. And we make the pointer of next, which is pointing to 2, equal to head dot next, which is pointing to 3. Right? We can just make that, and this will point directly, this will point directly to 3 in this case. So we'll make a line like this, pointing directly to 3. Right? Now, once we make this point to 3, what we can do now is we need to make the pointer of head's next prev, which is 3's previous, point to 2's previous, which is 1. Right? We need to make 3's previous, not point to 2, but point to 1. So what you can do for that is we can just write head dot next dot prev equal to head dot prev, right? So this will be head dot next, which is 3. It's prev, which is this point over here. We're gonna make it point directly to head's prev, which is head is 2 and its prev is 1. So we're gonna make it directly point to 1 like this, right? So now this is done, and I think this is all you need to do for this one. Okay, and I think, yeah, what else you can just do is you can just make this head next and prev equal to none if you want. I don't think it's going to make a difference, but I think you can also do that. So if you make this point to none, this point to none, you'll just remove this node completely out of here, and you'll get a final linked list, something like this: one, null. This is point to three, like this. Three. This is point to one, and this is null. So you'll just get this linked list. All right. So this is what the complete code for this is, guys. Let me just write the complete code over here, and else, basically, if it's in the middle, what we'll do is we'll just make head dot next dot prev equal to head dot prev, and head dot prev dot next equal to head dot next. That's it. This is all what you need to do, guys, in the final code. So this is the complete code for this question, and just see the code in action, guys, once. So, yeah, initially you just need to create a cur equal to head, so that we don't make changes to, so that we need to return the final cur as well, so that we don't make any changes to the final head over there, so that if we do make changes, we won't be able to return it completely. So we make a different variable cur, and we make a separate variable cur, which will just return and make changes to the head relating to it. So the very first step is we'll just move to the point which we want to move to the node which we want to delete. Very first case, we check if head dot next is none. This is for the very last node. If our head is of the last node, we make prev equal to head dot prev, and prev dot next equal to none. So over here, instead of writing this line, or the single line head dot prev dot next equal to none, what I've just done is made a new variable called prev, and made it point to head dot prev over here, and made prev dot next equal to none. So basically, it's the same thing. I've just made a bit more concise and readable for my benefit, and maybe for your benefit as well. All right, you can write this line as well, which is just more concise and simple. This is actually understandable on its own, but you can also write like this. You can create a separate variable prev, make it point to head dot prev, make it equal to head dot prev, and make that prev dot next equal to none. And this is the other way which I've done, which is basically the same thing. We made head dot next dot prev equal to none, head dot next dot prev equal to none when when we want to read the very first node in your linked list, doubly linked list. And else, what you have done is head dot prev dot next equal to head dot prev. I've just created a variable again, prev equal to head dot prev. I've made prev dot next equal to head dot next, right? So I've made this one. It's basically this line over here. One second. This line over here, the second line, where I made head dot prev equal to prev. Oh, sorry. Where I made head dot prev equal to prev. This complete thing is equal to prev, and prev dot next is equal to head dot next, and head dot next dot prev is equal to prev. This head dot next dot prev is equal to prev. Okay. This is actually, yeah, this prev over here. Okay. Head dot next dot prev is equal to prev in the red. Okay. So this is all I've done. In the end, I've just returned curve. So let's run the code, guys. Yeah, it's running, and let's just submit the code. Yeah, it's getting submitted. So yeah, guys, that's all for today's video. If you like the video, do like, share, and subscribe. Do let me in the comments if you have any doubts, or if you have any suggestions for me to make any more better videos. If you have any questions in your head, or if you have any suggestions for new videos, let me know in the comments as well. And do check out my podcast. And until next time, guys, thanks for watching.